Okay. In this week, we will start to digital signal processing, but basically the theory of this course. Okay. Philosophical thinking about the signal processing will be provided to this lesson. Welcome. Okay. So, the section 1, I write every topics this kind of section in order to easy to analyze the lesson. Okay. So the first topic is what is the root in equation. Okay. I will share these notes also in the classroom. Okay. So firstly, what's the root? Root means that if you have any knowledge about the x times x2 is equal 0, and so these x1 and x2 are the roots of the equation. But what's the meaning of this? The really meaning of this in the math or in real life applications. Okay. In order to understand this concept, we need to use the Pythagorean theorem. According to Pythagorean theorem, we can say that if we have any axis, just like this one, x and y, we can draw a line, which we call it the hypotenuse. Okay. And so, if we assign any variable in here, like this one, and we have this 90-degree dimension in here, and so we can define the new variable like this one. Okay. And so, as you know, as x square plus y square, it's equal to the z square. Okay. But this basic application of the Pythagorean theorem, but the meaning is different from the math, because if we assign to the y as the apple and another x is orange, for example, we can relate the two distinct features into the one form using the math, because if we know that this is the one component x, this is the y, and so this creates the triangle like this one with 90 degrees. Okay. And so these two features are separate from each other in the geometry. Okay. The importance of the Pythagorean theorem is that it combines combining the geometry with the algebra. Algebra means that we have the numbers in math, for example 5, 4, and we can scale it to the 10, 15 or any other else, but we cannot represent these things in the geometry easily. But the Pythagorean find us a way to combine these two features. Okay. And so if we have this information, and then we can relate to the apple with the orange one. Okay. Just like the Democritus notion, because everything is consists of the atoms, right? It's a philosophical thinking at this age, but now this is a physical or scientific fact, right? But at the previous age, he thought that we can build some essence to create the objects like humans or orange or apple. Okay. And so this theorem proves that we can represent everything, every object, everything in in mathematical domain with the notion of the geometric. Okay.
Again, what kind of relation between the orange and apple here? What kind of relation? I understand it.
Just see that. Just see that we have the apple, and so we can create the axis in here, okay? And so we can assign the 1 apple or 2 apple. It's rational, right? And so we have also 1 orange, 2 orange, right? We can scale it, but in itself or in this domain. But we cannot directly relate to the what apple and orange. But this theorem proves that we cannot scale these factors as a linear one. But if we use the square form, x times x plus y times y, which is equal to the what? Z square, right? This is a mathematical application. And so, if we use that, we can just simply say that x square is equal to the what? The z square minus y square, right? We can convert it, right? This is the basic notion, because actually we use this notion in 3D dimensions. This is a clear example to understand these things. Normally, at every object is present in the what? In the 3D dimensions, right? If we have the x, y, and z, and so we can draw the what? The some cubes in here, like this one, right? Just like that. And so we can assign the what? The 1, we can assign the 2, and we can assign the 3, okay? This is the dimensions or the features of this cube. But just see that this yx creates a 1 Pythagorean triangle, right? And another also creates the what? The 1 Pythagorean triangle, okay? And then if we use these 2 triangles, and we can create the what? The 3D dimensions. And so we can put everything into this one. For example, human. For example, orange. For example, apple. But mathematically, this Pythagorean theorem proves that everything can be represented in this form. Because the geometry and the algebra must contain this information, and if we have this nomination like this one, this creates the algebraic loop in here, and then we can draw this cube in math, okay? Any question? This is just kind of what if I want to calculate the volume value of this term, and so we can use the x, y, z, okay? We can use it. This is the dimension of these terms, because we know that y, x, and z are features, okay? But if I choose to what? This is 1, x minus 1, y minus 2, and z minus 3, which is equal 0, and then this formula represents this cube in each dimension. And so this is my cube, just like me. For example, for the Mehmet, okay? And so I have a root to specify me, right? Just like this one. If I choose to equalize this term to 0, and then we can define the specific cube in this axis, right? Yes, and then this x minus 1, it relates to the what? The x dimension, but for one specific roots, okay? And so this Pythagorean theorem creates this notion in continuous time, okay? Because, as you know, if you have to deal with the energy form is always in a square form, right? For example, if we want to calculate the energy, and so we integrate the area of these terms, because this area, kinetic energy or potential energy, can be converted to each other, right? Because this Pythagorean theorem guarantees that every conversion in 2D dimension can be done. Okay? Energy form can be converted to each other because it's a simple area form. And so, who proves that notion in 3D dimension? The Pythagorean. We can relate two dimension or two future by using what? This formula. Okay? And this 0 proves that this is homogeneous solution or unique solution for this system. Okay? And then if we have this axis in here, y, x, and we can build the 3D dimension or 4D or 100D dimension based on these concepts, because these concepts proves that the geometry is unbroken while is applied in algebraic form, but in the form of the what? The area form. Okay? And so this ratio is always present in this dimension, and we can treat the everything based on this information, just like the energy. Okay? Have you thought about the how can we potential energy to convert to the kinetic one? Have you questioned it? This is why we can convert the kinetic energy to the potential one, because we must obey the geometry rules and algebra rules in order to what? In order to represent the physical world applications or the energy forms. Okay? This enable us to what? We can convert the kinetic energy to the potential one, because it's proof of the what? This concept, just like the derivative, right? We can take a derivative for the what? The position with respect to what? The t, but t are independent, right? X is independent. And so how can we derive the derivative form of this term?
I saying to protect the geometrical shape
Yes.
relation. One increases, the other one should decrease.
Yes, but this theorem guarantees the whole the operation in the algebraic form. And so if we take a derivative form, and then we will derive the what? The algebraic results using these notions. Okay? And so what is the root in this term? The root 1, 2, and 3, right? And so this is the identical roots. This is the system roots. This is the independent roots to define what? A specific cube, just like you, or just like any control system. Just remember that you have the transfer function in control system theory, right? And so if we need to analyze this system, we check what? The roots of this system. But why? Yes, it explains the everything that the system is proven or the defined in that case, right? Just like this cube and the control system transfer function obeys these rules, and the Pythagorean theorem guarantees the whole this operation are in the what? In the unique form, or the what? To enable us to everything that's needed for your applications or the real physical applications. Okay? And so what is the meaning of this zero value? Zero value represents the what? If we take the root value, and then this must be equal to the what? The 0, because it defines itself at this root. Okay? This is the philosophical knowledge about the Pythagorean theorem to build the 3D dimensions or the physical dimensions in our world. You constantly use it, but you don't know it. The background of this information. Okay? We can relate to what two independent features by using these terms. So, if this is the case, and then we know about the root is represented by the what? Independent features, right? And so we need to convert it to what? The mathematical form, but based on the what? The geometry, right? This is the geometric axis. And also we need to define a specific function to represent the what? Algebra, right? Because if we have any information about these things, and so we should explain everything just using the numbers. For example, 5 kilograms or 10 joules or the what? 100 frequency. But each of the separate things are concerned or related to each other in the universe. Okay? And so this is why we can obtain this term to what? Define the geometric axis. Okay? Or energy forms. Because otherwise we cannot convert the potential energy to the kinetic one. Any question?
I have fruits for maybe apple and orange, they are independent. But for they are not independent because x is 0. No x, there is no shape. So it is not independent. They dependent on each other. With no x, no shape.
Yes.
So
And so we have the 3 roots, right? But if I remove the what, the one axis in here, and so we have 2 roots, right?
so removing it, not dependency.
Yes. Yes. So this is the other question. In real life, you don't have this specific kind of information, because in neural networks or the artificial intelligence, just remember that we create the axis x1, x2, mass, length, right? Because my name is Mehmet İşcan. This is a one axis, just like this root. I have the 80 kilogram. This is one axis. To what? To define me, right? In neural network application, we can create this axis as a root, right? Because if we have this notion, just remember that we can create the what? These terms in neural network, the mass and length, and this is Mehmet, right? We can train it, but simply we are using the 2 axes or 2 independent roots in here. Or this is what? This is Emre, right? You can say it. But in real life, we should deal with the what? With these notions, but in a different way. Another problem comes with these notions. In real life, we don't have any cube, just like this one, to be formalized for your operations. But the problem is that what happens I'm given the v values, but not the dimensions. For example, if we have some kind of information v, and we can create what the h, another variable, and so we can draw this line. V is a function of h, right? But we know that this must have what? The 3D dimensions, right? 3 dimensions, x, y, z. But in real life, you have the only one variable, h variable in here.
Why should we have 3D dimensions?
Because we know it. The V volume should be contained in the 3 dimensions, right? And so we cannot complete the model based on this information. And so at each feature, for example, the Mehmet has the 2 features, mass, length, but I have also what? The professor at mechatronic engineering department. This is my route, this is my axis, right? But I can use it or not, or I cannot define myself to what represents my features at every time, just like this signal, right? We don't know the how many parameters or the how many roots in here, but we know that we have only h parameter, h variable in here. We cannot know it every feature of yourselves, okay? And so how can we treat this information in this domain? So if we don't do any information in here, just remember that solution. We can prepare the what? The function, just like this one. V equal to, for example, a h over 3, b h over 2, c h, and plus d. This could be the what? The formulation of the v value. And so how can you treat these informations? We can convert it to the what? Root domain, right? Just like this one. This v can also be represented with the what? H minus h0, h minus h, this 1, 2, and 3, right? How can we decide the number of the roots in this equation? Why we need 3 roots in that equation? No, we have the 3 parameters in here. And just see that if we don't have any independent features like the 3D dimension, we have also the over parameter in here, just like this one. And so if we have the h value in here, and so if I want to build with the 3 independent parameters, and then we should give the 3, right? This is an exponential term in here. And so this is the geometric representation of this one, like this one, h1, h2, and h3, right? If I increase the 4 in here, like this one, and so how many roots should be utilized in that equation? 4, right? And so we can define the 4 independent feature to present or represent this domain, right? Any question? This is just one signal, but we can define the new roots by using this notion. If we multiply with another h value in here like this one, and so we can add one more feature, one more axis, one more algebraic numbers to represent this function.
Here, for the volume example, we get the equation because we know
Please be louder, and so everyone else can listen.
We got the equation of the volume because we know it is a 3D, but let's say it is not volume, it is another thing.
Yes.
How to get the equation of it, how to know if it is 3D or 4D or 5D.
Yes.
It can be anything.
Mm-hmm. Yes, and so I will explain these things as a Fourier series.
Okay.
Okay? Yes. But Just know it right now. These parameters is important, but what's the effective of the another parameters in here? We have also a coefficients a, b, c, d. In real life or the mathematical application, we have known these parameters, not this one. Just remember that if you have the transfer function, for example, s divided by s squared plus 2s plus 1, and so you have the a, b, c, okay? Not the roots of these terms, because we have dealt with these coefficients or the system parameters, right? And so this is the basic equation, and we want to prove to the notion of the what these terms. How can we represent this function? The main problem is that how can we represent this function to create its features in geometry? Just remember that if we have any function in here like this one, a times x squared plus bx plus c is equal 0, okay? And so how can we create the roots of these terms? Yes, x, x1, x, x2, right? And so this is the human, but this is Mehmet. This is again human, but if I use the x3 and x4, this is Emre. Okay? It's the basic definition of the what the mathematical implementation to define anything in real world. Okay? Or real concepts. Yes. Yes, yes, but we can select what the x anything. For example, it's a mass in here. X covers to the what the m1 and x length 1. But this is human. This is mass. This is length, right? This length L1 represents the human. This M1 represents the human. But maybe, what's your name? Ayça. Sometimes Ayça happen and sometimes Mehmet happen. Okay? But this is the mathematical formation of what the objects or the things or the essence of the universe. We can define anything using the what the math by using these concepts, right? This is the real meaning of the root. Root are the independent features of anything in the 3D or in the what? The abstract concepts. Okay? Yes. In geometry, this root creates the one axis with the what? With the 90 degree or the independent feature. Because if we use the what? These terms, just like this one, for example, if we have this kind of axis in here with the what? The 30 degree, x1 and x2. We can write the x1 in terms of the what? X2. Because this is the 30 degree. But if you have this notion 90 degree in here, x1 and x2, and so we cannot write the x1 in terms of the x2. Why? Huh? Yes, but why? Just simply thought that this x2 cannot project to the what? The x1. This x2 in the first case is a projection are contained in the one x1, and so this is rational. X2 projection is what? The rationalized or scaled with the what? x1. Where's the meaning of the ratio coming from? The ratio is simply in Turkish is a oran, right? But what's rational? In Turkish oranlanabilir, but in English it's the logic. That makes sense, right? This concept is true. It's coming from the what? The Pythagorean theorem. If this 1 apple, 2 apple, 3 apple is given in here, and so we can scale it. At this time, 1 human, 2 human, 3 human, this is rational. Right? But what happened if I choose the apple to orange? Orange, apple. This is not rational, but it must be because we buy orange or apple. And so how can we rationalize, or how can we scale this formation in here? Because it's the first case is linear and simple, right? And so how can we convert the apple to the orange? Okay, if we use the Pythagorean theorem, we can scale it, or we can convert it. Just like this one. This is the orange, but potential energy or kinetic energy can be given in here, right? If we increase the what? The kinetic energy, potential energy, and so this is 2 and this is 1, and in the second case we can write it like this one, 2 and 1, kinetic energy and potential energy. And so the energy cannot be destroyed or created, right? And then we can say that there could be a relation to provide this feature. And what is that? What is that? What is the rule of this term in which, or that providing us the potential energy must convert entirely to the kinetic energy? Because it's PA and KA must be equal to some constant and remain all the time constant. And so how can we scale these two things, or how can we take the potential energy and convert it into the kinetic one? This must be rule to what? To provide this feature. This preserves to the what? This ratio. And this is the Pythagorean theorem. Because in geometry, potential energy and kinetic energy are two independent features. But we can convert it from potential to the kinetic one, right? And so this area and hypotenuse must preserve this information. If you are using or decreasing the kinetic energy, and so this potential energy must increase. But with what ratio? For example, 3 or 2 or 10. If we use the or consume the what? The 1 kinetic energy, and so how much potential energy can be gained? And this must provide with the what? With the Pythagorean theorem. This ratio provide or enable us to what? To this feature. Okay? We can preserve the every energy. We can transfer the every energy into the another form. But with what? Based on this information. This is the basis of the what? The relationship between the geometry and the algebra. Because they have independent features, kinetic or potential or any form of the features can be combined by using these terms. For example, if we have the position, but the position depends all the time to the what? The time, right? It's a fact. But we can relate to time with the position, which we know it as a what? What? Velocity, right? We can have the velocity. The Newton found that every object has a mass in the universe, but at every object, if we apply the force value to this mass, we have the acceleration, the second derivative of the what? Position, right? But the second derivative, just like the root equation, because we have the two roots, acceleration, velocity, and position, right? And we can derive the kinetic energy, potential energy based on this information. But how can we do that in geometry and mathematics? The Newton used the Pythagorean theorem to build up to what? 3D dimensions, right? And then at each point in 3D, he said that there could be a mass or thing to affect the external things, which we call it the force value. It theorized the whole the things based on these informations. And we have used the everything in here in the real life and in the scientific concepts, okay? And so this hypotenuse and the area behind the what this triangle contains the what the constant energy form to what provide us the potential to kinetic one or kinetic to potential one, right? It's the basic notion of these things. And so the object is created using these concepts, because the objects must contain in the what? In the 3 dimensions in real life or physical worlds, right? But we should provide the geometric and the mathematic formulation to these things. With what? With using Pythagorean theorem. Okay? This is the fundamental rules to what? To math, with the interaction of the physical concepts. Newton is a brilliant scientific person because he thought that this Pythagorean creates the 3D world, okay? And after that, Newton theorized to what? We can put the mass or define a new variable to define the what? The moving or the features of the moving of the objects in the universe, okay? And after that, he put the definition of the mass and he related to what? The external effect, which we call it the what? Force. But based on the what? Pythagorean theorem. Okay? He founded the calculus based on this information. We will prove the derivative notion of this term just using the Pythagorean theorem in the next lesson. Okay? Have you understood everything that I'm saying right now? What is the root then? Yes, independent features. And what is the root? It is just a number in algebra, right? And what is the root? Root can be used to define any individual components for anything that we are dealing with. Okay? So, this is the basic notion of this term, but it's not enough to prove that. We should prove to what? To algebra with the geometry based on the what? The x squared plus bx plus c must equal 0. And so this equation is correct, and then we should generate the geometrical representation of these terms. Because what is the values of the root x, 1 and 2? Just remember that. What's the formulation of this term? Plus minus b divided by a, I think. I think this just kind of these terms.
4AC.
And so this the 2A 2A. Okay?
4AC değil mi hocam? B kare eksi 4A.
Okay. And so
Bir de artı eksi olması lazım.
yes. And so we have the two roots in here. But these two roots are independent of each other, right? And so in the next lesson we will prove it. Okay? After a 10 minutes break. Okay?